Good morning to all my students. I hope all of you are in good health and studying well. My name is Mansi and I'm your physics teacher. Today I've chosen a very interesting topic for today's session, that is electrostatics. Now certain concepts of electrostatics you have covered in your lower class. So what today I'm going to do is we will be revising those topics again and then we will move to the new concepts. As you can see, there are four images in front of you. The first image is of lightning. Now my question to you is, have you ever wondered how does a lightning occur? Let us take some time and think on that. Moving on to the next one, you see a pen is attracting paper bits. Now all of us have done this at some point in our life. When I was in school, I used to take a scale, rub that on my hair and try to pick those paper bits. And at that time it seemed like magic, but it is not magic. It is simply physics. So we'll come to that as well. Look at the third image. What do you observe? A boy is sliding down and look at the hair. It is all standing up in all direction. But we would like to reason out okay, why that is happening. And if you look at the last image, a balloon is being rubbed on the woolen sweater and then it sticks to the wall. So what is common in all these four examples? So let us quickly go through that. As you see, why is this happening? This is because discharge of electric charges takes place when two objects are rubbed against each other. So one object will lose charges, another object will gain charges. Now what kind of charges am I talking about? I am talking about the negatively charged electrons because they are the ones that are loosely bound on the surface. So when you rub two objects against each other, what happens is one of the object will lose electrons and the other object will gain electrons. So the object that loses electron becomes positively charged and the object that gains electron will become negatively charged. In all the examples that are in front of us, what is happening? The objects are being rubbed against each other. One object loses electrons and the other object is gaining electrons, and this is the reason there is transfer of charge from one body to another. So what is important in today's session is we will be talking about two topics. As you can see, one, we will talk about charges at rest. So electrostatics is nothing but study of charges when they are at rest, and second, what are the properties of those charges. So before we move on to the other concepts in electrostatics, let us quickly go through a difference between current electricity and static electricity. As I already told you, electrostatics is a study of charges at rest. Electricity developed on the object when they are rubbed against each other is known as frictional electricity. So moving on to the difference between current and static electricity is, in current electricity, what happens is electrons keep on continuously moving in one direction inside a conductor. That is one. In static electricity, the charges are at rest. So we will be talking about charges. We will be talking about those charges that are at rest. We will be talking about their properties. So here, the concepts that we want to look at are, as you can see in point number 3, we will be talking about electric field, forces between the two charges, or the potential energy field or the potential field that is involved. So once we are done with electrostatics, the next session that we will conduct will be on current electricity. So now before going ahead, there are certain conservation laws in physics that we need to keep in mind. You have already studied conservation of linear momentum. You have studied conservation of mass. Similarly, for this chapter, we need to study something known as conservation of charge. Now, what is a charge? Like mass, charge is also a fundamental quantity. How do we define mass? It just exists. It is a little difficult to precisely define mass. So is true with the charge. Charge exists. Okay. Remember, it is a fundamental quantity. Now, what does conservation mean? Simply, if I give you a very simple example, I have 10 marbles with me. I give 2 marbles to you and 8 marbles to your friend. Now, what you do is, you do not, for example, you don't need that 2 marbles. So you give away that 2 marble to your friend. So now your friend has 10 marble and you are left with none. But for me, what is important? The number of marbles that I gave you and your friend is still constant, which is 10. So the number of marble is conserved. Okay. Same is true with the charges. So in any reaction, the LHS and RHS have to be balanced. in number of charges or the total net charge. If you look at that statement of the conservation of charge, it goes like this. The charge of an isolated system meaning where mass exchange does not happen with the surrounding, is conserved. So a charge in an isolated system remains conserved. It is possible to create or destroy the charged particles, but it is not possible to create or destroy the net charge. As I said, LHS and RHS, remember that marble example. Internally, you two friends can exchange the number of marbles between you two. Doesn't matter, but the total number of marbles, that is 10, it still remains the constant. And so it's true with the. An alternate way to define the same definition is like this. Electric charge can neither be created nor it can be destroyed. It can only be transferred from one system to another so that the total charge on an isolated system remains constant. So taking one example, as you can see in example 1, there are two particles, not even particle. One is particle and another is antiparticle. We will talk about that in radioactivity. So one is electron, another is positron. Now positron has same mass as that of electron, but it has opposite charge. Electron is negatively charged, positron will be positively charged. So a particle and an antiparticle, when they meet, what happens is annihilation takes place, destruction takes place, and a chargeless gamma particle is taken out. So if you look at the LHS of that reaction, you see there is a positive charge, there is a negative charge. So the net charge on the LHS is 0. On the right side, there is a chargeless gamma particle. So the right side and the left side in terms of charge conservation is balanced. So the charge is balanced.